let me just, for the benefit of the audience who's over here, to explain what's going on. This is the tutorial at the InGARSS conference, and this is on standards for Geospatial Analysis Ready Data. We have 3 speakers: Scott Simmons, who is in India, but in Hyderabad, speaking at the vendor school that we are organizing at IIT. Then we have Liping, who has provided us his voice encoded slides, which I will go through after Scott has spoken, and then I will myself go through some more information related to metadata and a hands-on exercise. For the benefit of anybody who is online for this tutorial, this particular session, you will see the slides up there. If there is something that you can't see, we will also share you the slides later on. Scott's slides will be shared with you. But for now, just we'll stick to the time and we will continue. Okay, over to you, Scott. Scott is the Chief Standards Officer for OGC. Scott, you can share your slides if you want. They will be displayed.
All right, this is good. Sorry. You can see inside there, just for regular winter school, what other way about the use case until the use case in calculates? Then the diverse standardization, I can back and find that I need here.
From where will you take it out? Audio?
No, it's going to SDI. Yeah. I can hear you actually. We can like
You can't hear.
we can it's too faint for the
Yes.
that's everything we have maxed out.
We also maxed out.
Yeah, this is not fun.
They have maxed out to this.
Organizations. This is what you did. So we can see it started with I separated and the process of the some partners and organized so in short, their fields is data related to being versus pace of all the analysis we are going to do. So I talked earlier to this about the project we did on building energy, spatial data interoperability. If you want to now analyze buildings for how much energy they consume, how much energy they might produce, you have a number of different types of analyses. Yes, you can use remote sensing with thermal bands to see how the building is reacting to the sunlight. Is it reflecting a lot or absorbing a lot? And that makes an impact on its energy use. You can have ground level thermal cameras looking at leakage around windows. Those are a line of pointing at movies. And you can look at the geometry of the building, its three-dimensional orientation, which you maybe won't get from a satellite, to see if the roof line suitable for solar panels that you're latitude. And that's an analysis because the data set that may be in the sunlight imagery. In fact, it might be 3D building models that came from a completely different source. And so we have to look at all of these types of data which we want to do analysis. There's the last one, there was another interesting one. Living features and sensor integration. If I were to track a moving object in a video feed, and that video feed is reference to the Earth. So someone has a camera, in this particular case on a ship, pointed at the ocean, and is looking for small, unpiloted drone ships, maybe operated by terrorists. How do I track those features of real three-dimensional space from time? What do I have to do to prepare the video so that I can make that analysis? I don't just take the raw video. It has to have an origin and a footprint of the video. Those are the analysis ready elements I'm adding to that video so that I can then do moving feature analysis against my source. So analysis ready data, preparation of data for the analysis you need. We'll come back to that in a moment. Yes. Yes, so OGC has quite a bit of work in artificial intelligence, machine learning right now. We have been focused primarily on training data necessary to create those machine learning algorithms. So that moving features one project did use machine learning to extract from the imagery the objects that were to be tracked. And so in order to prepare the data for analysis, we had to do some training. The training data is part of that analysis ready process. And in that trains the machine learning algorithm, the machine learning has the data ready. So analysis ready doesn't always mean human analysis, it could be machine analysis too. Yes. So when we get climate change, we have a climate change service pilot. How are we identifying metrics for climate change? What analysis are we doing on a variety of data stores to ensure that we can perform climate change analysis and then later make calculations against resilience? A project of disasters, same thing. If we're looking at coastal flooding due to a tropical storm, what kind of data do I need to make an analysis ready? If I have terrain data and I'm going to flood that terrain, I need to know where sea level intersects that terrain. So my terrain has to be adjusted to be locally at sea level at what we're calling zero on the terrain data. It may not be that way in the original database at the process further. In our federated marine spatial data infrastructure, we looked at a lot more detail on that same problem. When we talked about connecting land and sea, if you are a ship coming into a harbor and you need some degree of automation about your approach to that harbor, you need to understand the tide, where you are at the tide, the bathymetry below you, how far above you are in the sea floor to make sure you don't run aground. You're piloting into a particular berth, a place in the harbor where your ship can anchor. What are the reference points you need to get to that berth? So you have to see land references to those lighthouses, tall buildings, towers. All of that analysis has to be performed by a combination of machines and humans. All the data must be prepared. So in these particular cases, a land data set of the harbor of Singapore. If you've ever been to Singapore, you know there's a lot of really tall buildings. Those tall buildings, from the land mapping perspective, are where people live and go to work. They don't think about those as aids to marine navigation. So you have to process that land data so that a navigator, someone in a ship, understands the relative height and distance and what lights might be on that building they can use to identify that building from another building. That's analysis ready. So there's a lot to make data analysis ready. We're now finishing test bed 19, looking more on collaboration of these kind of data from ocean data to space data in between. And that marine data infrastructure is continuing. Now we're talking about the offloading of freight, be it containers in Singapore or humans from cruise ships in the Caribbean. But all the data you need to analyze the impact of that offloading on the infrastructure. If I'm offloading 10,000 containers in a single instance in Singapore, that has an impact across the entirety of this value chain. I must analyze 10,000 containers getting dropped in a port against the rail infrastructure to get it to Malaysia. And how many of those containers can I move by train out of the port? And so that analysis has almost nothing to do with remote sensing, and everything to do with modeling the infrastructure. How fast can those trains operate? Where are those trains located? Where are the small transport vehicles to get them to the railway system? How many rail cars can come in and out of that port? And so I need to have all of that infrastructure mapped spatially, but also from its attribution. Is it ready to accept the information? And can I make that, or to accept that cargo, and can I make the analysis? So analysis readiness is quite broad, and we are retaining this very broad perspective at OGC. And they just continue and continue and continue. And so one of the things we want to do to start to help the community to understand how analysis-ready data might be used is we're standing up an open science persistent demonstrator. This demonstrator has two elements. One, data. Data that are analysis ready, data that have been prepared for the community to use for analysis. And those data are tagged. They have metadata that tell you for what type of analysis they're suitable. And those data will be up for persistence there for a reason, not for weeks or months, but for years. So for years, you will have access to well-described data sources that are suitable for certain analysis. So you can test your own analytical capabilities against proven and persistent information. And you can come back 2 years later and do testing of new analysis against the same data to see if maybe your analysis is improved. The second element is the services to provide those data. Long-lasting services in standardized formats, so that if you're getting satellite imagery persistently from the service, it's being served up via the appropriate OGC APIs for you to ingest in your software platforms. And so this persistent demonstrator is intended to be a multi-year, do it right, multi-decade look at content and content distribution mechanisms, so that you always have access to information to test against. And we think this will be very, very valuable to the open science community, as they'll have longevity in services and data to test against. Persistence is really important. So you'll see over 2024, this demonstrator will be going live, and you'll have access to analysis-ready data of a variety of scientific formats and suitabilities for your further use. And if we look at our next climate disaster resilience pilot, we're going to leverage our persistent demonstrator to put up these types of research layers of information. We're going to look at the user requirements, what information services are necessary to get data to the users. For the scientists, what type of data do they need, and what pipelines must we support? Precipitation data, temperature and wind data, and what perhaps remote sense information assists with that. We need extreme weather data. We need impact information. So what are the elements of data you need to calculate desertification or the land degradation, potential for landslides, wildfire or fuel loading and impact after wildfires, something that's very close to my heart because it happens right behind my house every summer, and even health data. And then finally, what data might we need to support strategic addressing of climate change impact, monitoring, reporting, and validation of climate change impact to society. And so those layers of research will be reflected in layers of services and analysis-ready data and persistent demonstrator. In all of those instances, we're trying to drive use cases and scenarios for ARD. So if we're looking at health in particular, look at gentrification. We need to address a population. This has become incredibly important in Japan. Japan has a huge initiative right now where more than 1,000 municipalities are using OGC data services for three-dimensional terrain and building data against remotely sensed disaster mitigation efforts, landslide, typhoon impact, etc., to understand how we might redesign their communities to better suit that aging population. At the moment, the elderly in Japan tend to live in coastal areas. Could those families be moved to slightly higher ground so that their places don't flood? Because if you're mobility restricted, if you're 95 years old, you don't run as fast as someone who's 25. How fast can you get away from flooding? Also, can we put these people in places where buildings collapse due to earthquakes? They're the least likely to evacuate in time. And so gentrification requires a lot of ARD. What type of data might we need to stand up? What kind of data feeds do we need? Are there synthetic data we can use to test? And again, can we do this in the coastal context? And this all sits in a value chain from that very raw information, it's not analysis ready data, all the way to final information. So where do we take those source pieces of data, numerical model data, predictive data, Earth observation data, raw infos on the satellites? Non-climatic data, information that's interpreted, and social science data, be that social science data collected in generic terms or social science data being collected by observers in the field. How do we then enable that data for analysis within the context? So if we're looking at climate studies, we need to take those data and make them ready for analysis in the context of climate information. That may not be the same for climate resilience as we would use for other analyses against the same data. So raw satellite data may be processed and made analysis ready in different ways, depending on what we're going to do. Climate resilience, we are very interested in drought potential. We may not do that same satellite image if we're looking at increasing the urbanization, be looking at the same type of analysis, we may process it differently. And finally, we want to produce products in the end. So those analyses are developing products. Be those products for a number of different stakeholders. And so the analyses change based on the product. And that's where I'm going to come back to the DRD discussion. So examples, some work we did in the last climate resilience product, pilot, of looking at the impact of different tree species plantings to enhance resilience to climate change. What tree species have the least negative impact on the environment, as in take the least water out of your soil, and in doing so still provide the most shade for cooling of your urban environment. And so how do you optimize planting a certain tree species to not degrade your environment by the way they grow, yet to enhance your environment once they are grown? It's a fine balance. The species do better in dry climates than others, but certain species have a very negative impact on the climate. So where I live, for years, we planted something called a salt cedar. It grows native in Russia. It grows really well in salty desert soils, but it also sucks the water table dry, and our water table couldn't handle the degree of load of these trees that the water tables in Russia could. And so they were destroying our aquifers, even though they were providing shade and handling our climate very well. So now we've cut them all down because we realized the benefit of offering shade and cooling was offset by the damage to our aquifers. And so we've got to optimize our trees. And for the native trees, we have old cottonwoods, growing a little bit slower, but don't take nearly as much water. So let's look at the drivers of standardization, how we're getting there. If we look at the recent climate data resilience pilot, we were looking at a variety of both individual and combined hazards and trying to find the minimum set of analysis ready data we could use to solve both those individual and combined hazards. So flooding and inundation, extreme heat and cold waves, drought, landslides, etc. There are interdependencies on many of these things. Landslides are usually initiated by soils becoming oversaturated with water. So a dry desert area is likely to have landslides if it has unusual flooding and rainfall. And so we need to be able to track all these independently, but we're looking at different analyses. That flooding calculation based on the rainfall for surface water runoff and when it's going to flood buildings is a different analysis than that which calculates as the soil oversaturated and the host of the collapse. Same source data, different analysis, different levels of readiness. So we're always there to work in the context of the project. And then we have to look at what types of tooling do we have available to perform these analyses. So if I have analysis ready data, do I need those data to be in data cubes correlated across different information sources and times? Do I need artificial intelligence to perform analysis? Do I have a digital twin concept where I've already built some simulations of my real world I want to analyze against? And what are those indicators I need to calculate? I need to make decisions. So I talked about DRD, that's decision ready data. You're not performing analysis as an end state. Analysis is great and it gives you an answer to something. Who cares if you're not going to make a decision against that analysis? So we have to go one step further. Analysis is not the end state, and analysis leads to us making decisions. And those decisions impact the analysis we're going to do. Yeah. I think we're getting there. The answer is not quite yet, but yeah, it's going to be good. CIOS does have a specification for analysis ready data that is remote since its origin, remote since the origin. So electro-optical Earth observation data, there's good spec out there for analysis ready data, analysis readiness. And this is building towards a more generic model. And then the next presentation will be really dives into it. So,
Scott,
great,
Scott, if you can hear me, Scott, if you can hear me, if there is any question in the room, could you just repeat it for the reference?
So we have the question for the room was, are there any standards now for analysis ready data? So I highlighted that's what's emerging, and CIOS have a spec in place that covers part of the problem. Oops, sorry. More from that climate change work we're doing is those impacts also change over time. And so the decisions we have to make change with time, therefore the analysis may change with time. And so it's a big and complicated picture. When we're thinking about analysis readiness, we have to keep a very open aperture in our minds of all of those things we may do to get a decision. And so if we're looking at drought risk in parts of China, that drought risk changes over time, and the kind of data we may have access to could change over time. If we're using Earth observation data that is of a visual or near-infrared spectrum, in the summertime when it's wet, we're not going to get good imagery because it's cloudy. And so we may have to have a proxy, a stand-in. Maybe we can use radar data that can tell you a soil moisture to give us some of the same information. So our analysis over time may change the dependencies of the data we can support. And I know your brains can explode when you start thinking about these complexities. And so we have to think of all that before we start talking about standardization. And if we're going to standardize too narrow of an answer, it doesn't support 80% of our use cases. Ultimately, we need decision-ready data. Decision-ready data terminology primarily came out of the defense community, and it was meant for targeting. So the decision-ready data standards and specs that are out there right now are meant to put a missile onto a tank. And that's where the concepts came from. We're not going to do that today in the room. None of us have the right hardware in place to do it. But remember that in the context, because that's an exceptionally fine-point decision. And that decision is more than just, is it in the right place at the right time? Is it the right time? Is it a friend or my enemy? Do I have the capabilities to get to it? And so that decision readiness has a whole chain of consequences to get there. And when you talk to the defense community, you may not always believe it, but they have to consider aspects of humanitarian issues. Are there other people that could be hurt? Be careful. And all that other analysis they need to perform. So that decision tree in the defense context is often the most complicated you ever see. And we like to use that as our endpoint because they have to consider so many more collateral issues than we normally do if we're trying to determine if it's if a 10 by 10 meter square ground is going to be drier next week than it is now. We don't have as many consequences to deal with. So leaving that decision-ready heritage in place, ugly as it may feel at times, does give us that fine point of complexity that we want to address. And then we come to the data. So we've got decision-ready data, driving the analyses, driving the data themselves. So it's a DRD to ARD to D chain. If I know the decisions I want to make, I can start thinking the analyses I should perform to get to a decision. So work backwards. I have a decision I must make. I need to determine whether this building needs retrofitting for its thermal characteristics. Does it need different insulation, better windows, better air cooling systems to make people happier? That's the decision I have to make. So I need to think about, okay, what analyses do I need to do that? I need to understand the thermal characteristics of the building. I need to understand how expensive it's going to retrofit. I need to understand, is my local power supply have enough current to control an air conditioning unit for this building? Because you know that's an expensive process. I need to know, do I have a budget to do any of this? All those analyses have to occur. And there, based on those analyses, what data must be tracked? Okay, for my thermal characteristics, I want some overhead information about the general characteristics of the tree cover in the area. I need to understand the terrain, to understand when I get shadows, other buildings. If I know there's a really tall building in the afternoon getting in the shadow, it keeps this building much cooler. Therefore, I know the three-dimensional aspects. I need to understand the cost per watt hour of power in this city, how much load I can accept. Those are all the data I'm going to need to make that decision. And so you can't do analysis ready data without the other two pieces: decision from the analysis and the data that underlie those analyses. So to get there, what's our path forward in OGC? The presenter after me will have a whole lot more information in these details. We've adopted a new analysis ready standardization effort jointly with ISO Technical Committee 211, ICTC 211. That's the group that met last week in Delhi. And with very active participation from CEOS to develop an international standard for analysis ready data that is universal for any type of geospatial data. So we are leaving out of our scope non-spatial data. I talked about the analysis for this building for cooling. We're not looking at necessarily the capability of the power grid as part of the analysis we might have to do. We are looking at spatial data. We are starting with the CEOS specification, which works for conservation data. We are doing this with a foundation of current OGC and ISO standards. So we have standards to describe all the types of data that might be analysis ready data. We want to follow those standards. If we're talking about imagery, we want to use Geographic. That's a universal standard, OGC standard for imagery. If we're talking about multi-dimensional data, we might want to follow a coverage model that OGC and ISO share, or something like ZAR, which is a very popular cloud-native multi-dimensional data store. So we're going to follow those standards. We are going to follow our processes, which means all the stakeholders come in, and we'll publish it jointly to organizations. So we have a new standards team. It is joint amongst these organizations. The OGC Standards Working Group and the ISO committee will be working together on this. And we're going to do this not just for Earth observation data. So we would have ARD for all types of spatial data. So if you look at the parts to be developed, currently the framework is very far along. We can start with the CIOS framework. And so we're writing a geospatial ARD framework that will support all types of geospatial data. That will be the organizer. The other parts will plug into it. So when I talk about analysis ready, these are the basic definitions I use. The first part, the second part after that, is Earth observation analysis ready data. So CIOS has that in general. We're going to break it into more specific pieces because you need to look at Earth observation data through different lenses. So we'll have land, ocean, and atmosphere. And remote sensing satellite can collect information that hits each of those targets. A single sentinel image or a single landside image gives you information about the characteristics of the land, the thermal and multiple characteristics. The same with the water, how clear or dirty that water may be, and it's telling you about the pollution or the humidity of the atmospheric column through which it's looking, because after all, the image is reflecting from the ground, it's responding to that. So Earth observation data can meet all three of those criteria. And so we're going to segregate the ARD characteristics for the use cases in mind. So the first three start looking at Earth observation data. Then we're going to look at an Earth system model. So what are the other types of information we might need, and finding what services are necessary. Within all that are other types of data, and more parts will be included. So parts 5 and 6 will start talking about non-traditional Earth observation, as in collected from a satellite aircraft or other things floating above our heads. And we'll start looking at vector data. If you're doing analysis on a road network, how is that road network feature data for vector data? How are they ready for the analysis you need? It's the same problem intellectually, right? We're performing analysis, we have data. If I perform analysis against pixel versus vectors, we're all geospatial professionals, you're all a lot smarter than I am. You all know that it's much of the same kind of things. It's a spatial relationship, it's the characteristics of what I'm looking at to solve the answer. So the ARD spec will be general for not just imagery, but feature data sets, 3D data stores, terrain data stores, and any other spatial information. So part one, the hardest bit of that effort right now, and where the most discussion is occurring, is on that getting a container generic enough to handle any type of spatial data, yet specific enough to actually work. Because a standard can be written very generically to handle anything, and so generic that no one can implement. It can also be so overly specific that we can use it for just Earth observation data from the satellite with 4 bands, from a satellite with 4 bands that collects 1/2 meter pixels, and not work with a satellite that has a 10 meter pixel range, or not work with the feature data set. So we have to balance that, and that's the hard part of part one. But once that framework's developed, we'll plug in as many parts as we can, but anything in the community can come back to our organizations and say, we need a part for this new type of data. It is highly possible that these EO parts won't be well suited for radio spectrum data. They might work for radar because radar we treat a lot like other phenomenology where there's sort of pixels. Radar doesn't work quite the same way, but we can do it in our heads. But if we're looking at radio signals from mobile devices, from transponders on ships, radio frequency data, and radio frequency bandwidth from discrete sources, there are satellites collecting that. The Earth observation parts are not going to be well suited. And so we'll need a new part to handle that. So do keep in mind as you explore that, and as you hear more discussion about the next bit on this matter, that you have an opportunity to recommend parts and other things we may have to do.
Scott, we have a question from
Yeah.
here in the room. Can you be loud and say that and introduce yourself?
I'm Shubham from Galaxy Space. I'm working as a head of data. So this, the data standards are very important for me. So I was just wondering, I had a talk with Harsha as well. So are we having any kind of, standard products, standards in the pipeline for strictly the radar data? Because what I see is still it's being distributed in GIS format, but still we have other standards as well, like sensor independent complex data, sensor independent derived data. So for radar, especially, do we have any kind of framework where we can decide these standards?
So there's a little bit of a question. Do I understand asking about not just the standard for the data, the analysis readiness of the data, but for the pipeline to use those data?
Just hold on, Scott. He will repeat his question. I think the main question is about radar data and yeah, and
So basically, what I want to ask is
yeah. Now you can say. Introduce yourself again here.
yeah. Hi Scott, I'm Shubham from Galaxy Space. I'm head of data over there. So we recently will be yeah. So we'll be launching a satellite probably next year, next quarter of the next year, last quarter of the next year. So what I wanted to ask is that is there any specific standard or any standards in the pipeline for radar data? Because what I see is it's still being distributed in the GeoTIFF format, and I don't think that GeoTIFF caters to all the needs, because probably with the growing evolution in the SAR data, I think there is a need for good level of standards in SAR data. So currently, what I know is that it's sensor independent complex data, SICD and SIDD, sensor independent derived data. These are the formats which are being used for radar, but not to at a very large scale. So what do you think? I mean, do we have anything from the SAR perspective, from the radar perspective? The standards are going to come in that in this direction?
So excellent question. Those of you who maybe couldn't hear our last speakers. So the question, are there any standards emerging or out there for radar data? Recognizing that traditionally many of us use a pixel-like structure for radar data, but what radar is measuring does not always lend itself to just being represented as pixels. There are all sorts of other information available in radar return signature, and some of those are at different resolutions and different phenomenologies that are simple to represent the gray and white blocks on a map. And so the answer is not really. We would like to have core standardization work on radar data. The problem has been brought forward a little bit, but we've not brought enough experts together. And so if you're interested in helping, we also have the radar set community out of Canada, the TandemX community out of Europe, and others very interested in some more uniform radar standardization to try to simplify over some of the sensor independent efforts that are out there, because they've been, I think, broadly adapted to even more sensors than just radar, and they're in many ways almost too generic and too complicated. So yes, the unfortunate answer is no standard yet, but radar is informing this ARD work, and we hope it will lead to further work on standardization in OGC or elsewhere on radar data patterns.
Hi Scott, this is Harsha. For everyone online, I'm Harsha from Open Geospatial Consortium. So Scott, also from the NRSC, the National Remote Sensing Center in India, actually is collaborating with NASA, because we have a joint mission coming. It's called NISAR. So NRSC has reached us and asked us if we are working on SAR data standards as well. So There is also a lot of interest in the Indian community on SAR data standards at this point in time.
For those in the room, Harsh Emergency just noted that some of the joint work between India and NASA right now is also expressing interest in SAR and radar data standardization. Sure.
And this of data. How does these aspects impact the processing of ARD or any of these navigation or
Beyond just what we're talking about for Rio here is the other characteristics of the data.
How the factors of ARD for land, ARD for or at least plans.
Okay, right, so then, the question is about, do these standards and what else are the dependencies for the data that's coming, because it's not just a single bit of data that's being ready. The data has collection frequency, it might get recollected. There's a processing chain, data get processed, etc. And so that is in part handled under this standard. So if there is a readiness calculation on data, that readiness may have been processed. And so retaining the processing information and its history is an important part of ARD metadata. And so, yes, we are intending to retain in this standard more on the information with respect to any individual set of data and its history. Further us is very important. And that's also some of the evolution of the metadata standard stuff. With respect to the more generic, it's a type of data, a particular collector, and it has a collection frequency or refresh. The ARD standard, I don't believe is going to cover that as a characteristic of any particular data set, but it's something interesting to consider if there's maybe other ARD parameters to talk about. If you're using this data, here are the characteristics of that center and how you might use other data from that system. So I think that's something that we should consider. I don't believe it's partly I haven't read the latest drafts, I'm not sure. I don't know.
Yeah, thanks, Scott. And just to be mindful of time, we have to wrap up soon. So let's have all the questions at the end now. And just very, oh, that's the last slide. Okay, and just to also answer the last question, since we were discussing this in New Delhi in the ISO-GC meeting, we are speaking about different levels of analysis. Like in CIOS, there is this level 1, which is data coming from some kind of sensor, so more closer to the instrument, and level 2 being some kind of process data, and level 3 being thematic data. There are 3 levels of data, and ARD standards, the core, is expected to cover all of that. Just for a clarification, you could repeat that for those in that room.
For those of you who didn't hear, the ARD standardization effort is intended to have 3 levels of increasing sophistication of the kind of information collected. And so I think also we'll see that in the team slide, probably, right?
Yes, yes.
Or,
And I will present that to the people over there, but I will present this to the people over here today. Thank you.
okay. I have one more question in the room, and then I'll stop sharing. Yeah.
When the data in here is not really a big part of it, I can find out data already data. That speaks about how quickly and what is the high, what is the overlap, when the right overlap, what connect how to work. It is not, it is that more important to create the data. But once you create the data, you may find something out there.
Now, so it's a question about, we talked about findable, accessible, interoperable, reusable. But before that, someone actually has to create the data. And are there standards for the creation? How to collect, if you're flying aerial photography, what are the characteristics? The height to collect for certain resolution, overlap, stereo, all those things. And there are standards and specifications, but OGC and ISO do not manage this. And so we have both, as organizations, made a decision not to be writing specs and standards for the business of collection, because there are industry bodies that do that already and have already written good standards for that. And so we rely upon those. And an example that I'm familiar with is much of North America uses the AS/BLRS standards for accuracy, for description of aerial photography, flight planning, and all that, and we rely upon those. Related a little bit is there's a new standardization effort starting in ISO, OGC supporting for maintaining a registry of all the quality measures and all the parameters that go into those specifications. And so we will have a register of the measurements when we use the drivers, but we will write the specifications. So you have to go out to the industry bodies to get those. President, I will stop my share.
So that was the first part of what is our tutorial 4 for analysis ready data standards. And now I would like to know two things. Since Scott is dealing with another 26 people over there, I couldn't customize it a little bit. I would like to customize this. Jaya said we will have 4 or 5. I think we have much more. So I do have the talk, which will run for half an hour, but we have a lunch break in between. I do have some slides, but I want to make it more interesting. I want to do a more hands-on activity on ARD, metadata to be specific. So if you are interested, please point that out so that I'll cut down on my slides and make it more interesting. Is that fair enough? Okay. Just to very quickly go on to these slides, just to give the context, Scott is right now in the winter school, and this is day 1 of the winter school. And we also have a developer workshop co-organized in the winter school. This is on 15th and 16th. And in case anybody is interested, that's a scan code. You can try to, we will have more details available later on. And then let me go to, this is going to be my presentation, which I will talk about. So these are the topics that I will be covering. And I think more importantly, I will focus on this. We will spend some time with how many of us are familiar with metadata or the standards for metadata in general? Metadata, yes, but metadata standard, what are the components? So we'll go through these slides, so just to familiarize you with the metadata standard, and then we will try to do the hands-on exercise so that you not only appreciate the complexity when it comes to what we call as ARD and the metadata for ARD, given the level of different complexities that are involved. But also, I would like to get your input in terms of designing the metadata standard for ARD, because it's not established, it's not carved out in stone. It's going to see lots of revisions, And so this is one of the outreach activities under the ISO OGC ARD working group to ensure that whatever we are doing makes sense, is applicable, so and is implementable. So we will work on that. So now I'll just quickly go to the presentation of.
Will we have access to this presentation?
Yes, all slides are open. Scott's slides will be made available just in case. Of course, the Zoom video recording will also be there, but we will also provide you our recording. All the winter school recordings are also going to be published, available to everybody. So, and we hope later on some of you will join the next winter school, possibly because this is really a unique opportunity across the world to listen in person, learn in person. And the discussion in OGC has been always, how do you create education material, learning material on standards when the pace of development of standards is so fast that if I made a material this year, it is not applicable next year. So having such an opportunity to know the baseline, it's very important. So this is the voice annotated presentation. Liping was here in Delhi, and of course he had to rush back, but he is very keen to get feedback from you. This is his presentation.
Hi everyone. I'm Li Qingyi, professor and the director of Center for Spatial Information Science and the System at the George Mason University in Fairfax, Virginia, USA. Thank you for inviting me to give this presentation. My presentation title is Geospatial Data Analysis Ready and Standardization. Hi everyone. Here's our outline for today's talk. I'm going to first discuss geospatial data and the challenge in the application of geospatial data. And there is a solution for the challenge. We want to standardize in analysis ready data. Then I'm going to discuss CEOS, Committee on Earth Observation Satellites, and CEOS ARD. And then I'm going to discuss the joint ISO OGC ARD standardization process. Then we're going to discuss ARD standard working group and the ISO 1976 leadership. After that, I'm going to discuss the ARD standard development platform, the ISO 19176 Part 1 timeline, the project status, and the outline draft working document. And I will explain the top level UML model of ISO 19176. And I will invite you in the community to participate in the standard development, the ARD standard development. Thank you. According to common definition, geospatial data is a data that can be located on Earth. So because we are living on Earth, so almost all data we generate are geospatial data. According to statistics, over 75% of the data that human society has collected are considered geospatial data. Geospatial data have a very some very special features. They are very diverse in terms of data quality, because different people collect the data and the quality may be significantly different. The data sources are very diverse and the method of collection of the data. For example, we use the field survey, use a different sensor. The sensor could be remote on the satellite or on airplane or UAV or on ground, or generated by different models. So the measurable collection of data is very diverse. And we have a huge number of data format. So in data format and also the data forms. We have imagery data, we have data data, we have feature data, and each type of data are different from other type of data. And also we have more type dimensions. There's a data, maybe spatial, we have 3 dimensional X, Y, Z. And we also have temporal dimension and the class is semantic dimension. So we have a multi-dimensional data. And by far, remote sensing is one of the major methods to create geospatial data. Geospatial data has been widely used in all aspects of socio-economic activities, so from like urban planning to agriculture to resource management to environment monitoring and disaster mitigation into climate change. So it's a very useful data. But typically, before we use geospatial data set, we have to do a lot of pre-processing before the data set really can be feeded into applications that make useful information for the evaluation of applications. So those pre-process required pre-process include remove, reduce the error in the data set. For example, we need to do the geometric flashing, and we need to do color mask, and the other kind of process to process data into a certain level of accuracies that can be accepted and by the application. In addition, we also need to reformat or reproject or subset the data sets to make the data useful for specific application. So those pre-processed electron makes the geospatial data set analysis ready.
So here I will just take a pause and contrast this with what Scott was saying, that analysis ready data is essentially all kinds of geospatial data, right? And so this particular definition, the pre-processors make geospatial data analysis ready, is a very Earth observation oriented view. And the current CEOS, standards on analysis ready data, is limited to this definition. So just wanted to point that out, because even in our metadata exercises, we will have this same problem or same conundrum, let's say, when we will discuss that.
Certainly, we face a huge challenge in making geospatial data analysis ready. First of all, a typical geospatial application requires multi-type of geospatial data on multi-source. And those data has been pre-processed into an analysis ready form before application can utilize the data. And typically, such pre-process takes up to 80% of time in the entire life cycle for geospatial application. So this is a huge amount of energy and efforts needed for pre-process data into so-called analysis ready form, so that can be ingested in the analysis by analysis software package. So this is certainly a huge challenge for the application, because to every user, they let users their knowledge in the scale of selected pre-processed geospatial data, because many average users, they don't have enough knowledge and skills to pre-process data. Also, to expert user, it's still take a tremendous amount of time and labor to pre-process the data, making the application of geospatial data very expensive, because we need to spend a lot of time investing in the facility, computer facility, and making less lost time to pre-process the data. So this is why it's use of geospatial data in the application is still very expensive. From the typical geospatial applications, so we can have following observations. First of all, geospatial data can be utilized in many different applications in a certain domain. But for each application, they need to do pre-processing. It's repeat the work, and because when I use the same data sets to his application, he did the pre-process. Another time, use the same data set for his application, he also do the auto pre-process. So basically we have a repeatable pre-process. This means that waste the time, resource, and labor. And we can group the pre-process into three groups. The first group of pre-processes that all needed by our application, for example, geometrical and radiometric collection. And the second group of pre-processing is needed by many applications. For example, we want to reproject the data to a specific data projection. And the third group of pre-process is application specific. This means that one application maybe uses this pre-process, another application maybe uses a different pre-process. It's not all used by different applications. So this kind of thing, like someone wanted to do the moving and the average for a specific application. So those are application specific. And another observation is that many data producers will generate the same type of geospatial data. For example, many space agencies are all generating physical near-infrared remote sensing data. So those data types are same. The different geospatial data have a different. So the last observation is a different type of geospatial data with different application domain, and they need a different for pre-process difference in the data type in the application domain. So basically, we for the same type of geospatial data, we can have a common set of pre-process and also a common set of pre-processes that are needed by many different applications, and we also have a set of application specific pre-process. But the different type of geospatial data, they may share some common application, share some common pre-process, but the majority of pre-process will be different. From the geospatial, with above observations, we can propose a solution for the challenge. Basically, so I just say that allows for pre-process are common to a specific data type, and so if a data producer can generate pre-processed data by applying the common pre-processed data by majority of the potential application of the data set. And doesn't make the pre-processed data instead of in-processed data available to user. And in this case, this can save a tremendous amount of user time and resource. And the greatly lowers the bar for the application of geospatial data. And we can call those pre-processed data set analysis ready data because they already apply many different pre-processes. So when user get the data, they are almost ready for their specific applications. And if all the data produce the pre-processed data by using the same set of pre-processing and pre-process the data to a specific set of quality requirements, and the data set from different data producer or data provider can be automatically interoperable. So the required pre-processing in the quality specification, if this is set by the contents of state for the community, then those the set of required pre-processed quality specification is the standard, and we call this ARD standard. So basic idea is that let data producer to pre-process the data based on a common set of pre-process the community think is necessary, and then generate such product for user to use instead of providing user with an pre-processed data sets.
Okay, so there are more slides I will not go through right now. I want, Li Peng had asked me to ask this question, pose this question. I will ask that question, and I think then we will break. I understand there is 1.5 hours after lunch that I will mainly focus on the hands-on exercise. But the question that was posed by Li Peng before we go to the next slides and next material was one, what do you think? I would like to have some inputs from you. Are the common pre-processes that you would do with any kind of data? I will just give you some hints. Noise, outliers, bunching, or let's say arranging data by data quality, by temporal, by spatial, those cookie cutters, as we may put it, before you analyze data. So which, and do you have any other? These are some of the things that are normally discussed, and we will have them during our exercise also. So do you have any common pre-processes for data that you think should be part of ARD? And remember, poise this to the bigger geospatial data ARD that Scott was speaking about, which included all kinds of vector and all the different levels of data sets. So any inputs before the people usher us out for lunch? Any thoughts, any inputs? Noise, outliers, and bunching or clustering, or putting things together so that you can run them in batches. Yeah. Compartmentalization. So yeah. Other than that, yeah.
In terms of remote sensing data, the first thing is calibration.
Okay.
Getting the calibrated data.
Yeah.
To get the we talk of multispectral measurements, optical data.
Right.
Getting the surface reflection data is the first thing we really like on.
I mean, it's a calibration before, okay, so calibration, right, as a pipeline, okay, calibration. Yeah, that is true, we have that in our, we do have, I just gave you 3, 4 that is it to my mind, yes, calibration is part of the activities that we are looking at here. Yes, any other? I want to keep this very interactive, right?
Maybe adding to his answer,
Okay, no,
the level of.
Actually, if you can name and your organization.
We'll do that during lunch. It's a. Yeah, yeah.
Satellite provider, so it passes perfect. What's your
So myself, Anish called. Currently I'm working with social climate in India, space in Bangalore. So. Basically, I'm a genetic marriage professional. I'm an IRS alumni actually.
Great.
So, like, I've been working a lot in government organizations.
No, that's good idea.
So now we're back to that, so, the answer that we gave. So, but in addition to that, so, since you mentioned compartmentalization, you mentioned time.
Yeah, time, space.
And space.
Yeah.
So maybe level of processing can also be one.
Okay.
Criteria.
Okay.
Or the data quality.
Yeah, that definitely is. Data quality is definitely, yeah.
On the level of processing.
Yeah. Okay. Anybody online wants to speak up? I don't know whether we will hear you. Odisha, Rahul, InGARSS volunteer, I guess, is here. But anybody wants to speak? No. I don't know if we can even hear them, but nobody's even unmuting themselves. Yeah. Any other thoughts?
So yeah, I'll start with the introduction. My name is Harmat. I work for GISE. We're building edge computing capabilities. So this is more towards edge computing rather than the overall ARD part of it.
Right.
To accommodate more models on board and the limited computing and all. Most of the models that we've seen use a chunk from the image. So what we've come up with in our pipeline for pre-processing is that chunking part of it.
Correct. That cookie cut. Yeah.
So no, but it's not like exactly sort of a cookie cutter, but it's like breaking down the image as per the user's requirement. Like,
Right.
So we chop the area as per the user's area of interest and then just provide that.
Correct.
It's not like a moving.
Right. Yeah, understood. Just the segmentation part is.
Do you do it? But hi, Anand. So my question is, do you do it after the processing?
No, this is pre-processing.
So, because they are processing on board, right? So
Right.
they have their collected data. The data is analyzed on the edge, and then the data has to be downloaded at the client side. So you're saying you're cutting out the data after processing on the edge.
So before running the model itself.
Yeah, before. This is a pre-processing.
Pre-processing part itself we are talking about.
Okay.
Great. I took note of that, and I think before you kick me out, we will come back. I will have some hands-on exercises. So hopefully I get some printout. So we will do that, and we have some slides left. I will keep my slides to bare minimum. So we'll try to finish and wrap it up in an hour, not like 1.5 hours that you're saying. I can try to finish it in an hour. Yeah, is that fair enough? Anything specific that you want me to cover, I can, because the rest of them are, I mean, bound by constraints. I am not that much. So if there is something that you want me to speak about, I can also try to include it. You know that.
I have one question is, so this presentation covers that pre-processing is required for any data to be called as analysis ready data.
That is for, I told you this is what does analysis ready mean? So there are many perspectives on that. This is the CIO's perspective on analysis ready data, which presumes that the pre-processing makes it analysis ready. Okay, but it is not the only. As we heard from Scott, there is from ARD to DRI, and actually, if you even within the OGC parlance, the any data that actually helps you to create the DRI is still an ARD. So if I were to say there is the sensor, there is where I have read, and then I have an analysis ready data 1, analysis ready data 2, 3, 4, till I get to the DRI, which is not to be analyzed anymore. So there is no requirement on that DRI to provide how it can be used and all those details. So you are not going to do any pre-processing for that as well. So that is the only definition that you can see. But are we there yet? Absolutely not. Will we be there in a year or two? Most likely more than not, because the amount of money and resources that are being spent to have this. Because why is this important? As Scott was saying, if I have a sensor and we have multiples of them, and I have metadata and amazing stuff, that is going in, and then this whole first level ARD, which is what we were speaking about, the levels, and so this is coming from it will mainly have this sensor thing, but then over here, you are getting all this provenance. Now, problem is, there's some Gartner study, and in fact, even GMU had this report that most, even mainly in climate models, and it is at least 4 levels that you process to get to what we call as climate indicators, or at least 4. Now that means we have to be very careful in terms of what we are removing. So a typical thing is outlier removal. If I remove the outlier, I might be actually removing something that is critical. Again, it is not by design that we want to remove the outliers for everything, but even noise, or even the segmentation. If you are going to cut on the border where the interesting thing is happening, but as long as I document it, I can trace back and say, I missed something here. So that is why there is a huge interest in building these interfaces across ARD levels. So that is why we are still hovering around this part mostly. There are some very few things that are there in a level 2 or level 3, but we are mostly hovering here. But in another year or two, you will see the entire ecosystem landscape, and that to me is scary as well as amazing. Because we are speaking about rushing through this. That's why it's scary. But if you don't do it, it's like we are getting too late. So that's where we stand. Thank you. We assemble at 2.
So I have a follow-up question on that. So recently, some of the trends that I saw in edge computing is people are getting DRI data at the raw level itself. So they are not doing any noise.
Correct. So yeah, that
outliers or all those stuff.
Yes.
So how does standardization step in that case? Because that is technically not ARD as per your definition.
Yes, and when you don't say that you have done certain things, when you don't provide the documentation, what has been done to make it analysis ready for the analysis that is being done, there is a problem that you will end up with wrong indicators, right? That is what you are pointing to.
No, so I've seen like segmentation model, like detection model, object detection, or maybe cloud segmentation model run on raw data itself. So there's no denoising or outlier or anything done.
Well,
image is taken from the sensor.
Yeah.
The model is run and the DRI is ready.
There's not going to be any standardization of the process. There will only be best practices. Okay. There will be engineering reports to tell you this is how you should do. For example, the engineering report on climate, the climate pilot engineering report tells you how to do. But I don't think there will be a standard per se for the process. There will be mostly best practices and, but the interfaces, which is where the standardization is will be there. That's what we are speaking about here. So we stopped at this slide last time to say that the required pre-processes and quality specifications set by the consensus of the stakeholder community. Now, this is a very heavily loaded word. And the community that believes that they can do so.
Here I introduce the Committee on Earth Observation Satellite, CEERS, because CEERS play a very important role in the ARD movement. So CEERS is an international agency coordination committee. It coordinates the surveying satellite remote sensing activity in the world. And all major space agencies in the world are CEERS members, for example, NASA, USGS, JAXA, the Indian Space Agency, all are members of CEERS. And the CEERS member agency produce most of public domain remote sensing data in the world. So they want you looking into the scientific application about remote sensing data. Majority of those people utilize data produced by those space agencies. So here I introduce the committee.
This is important.
CEERS defined ARD analysis ready data because CEERS ARD. CEERS ARD are satellite data that have been processed to a minimum set of requirements and organized in forms that allow immediate analysis with a minimum of additional user efforts and input of predicted force through time and with other data sets. So you notice the CEERS ARD definition that are narrow because they only concern the remote sensing data. And the second is the definition is quite a figure because what's the minimum set of requirement. And another is the immediate analysis. As I discussed before, for single data set, but for different application, because the user maybe use different application software, analysis software,
Product family specifications.
different
That two of them printed in the part of your.
So actually, even with the process of so-called users still need to do some process before we can use. But this even there, with a significant pre-process efforts applied by the data producer, the user, the process will come on user side has been significantly reduced. So this is why there is advantage to the user community.
So while CEERS ARD is a specification, it is not a standard because one, it is not formal. Second, it is not testable. Third, it is a community spec. Community spec, which is still evolving. There is no agreement that this is. Although they have also, you will see there are different versions of the CEERS ARD, but again, there is no acceptance. When we say stakeholder community, there is no acceptance right now that we have adopted, we do hereby adopt this to be our constitution. No, there is no singular acceptance. Some group of people have said this is a good thing. So it is not a standard. So what we are doing is standardizing the ARD spec through a joint activity between ISO and OGC. And believe it or not, half of the members in that committee, including Professor Li Ping, is actually part of the CIOS working group as well. That explains why we are so heavy on the CIOS. Now, what another thing that I wanted to point out was, okay, I think I'll let this slide go, but what we are doing in ARD spec or ARD standard is to ensure there is backward compatibility with the CIOS spec. That means anything that we specify as a standard, which will not make the CIOS data, ARD data, non-ARD compliant. Now that's kind of a constraint that we have imposed on ourselves.
So the approach for develop the ARD standardization, we have developed an approach towards the approach basically to the sales support in the OGC disaster pilot 2021. Included action item to develop a recommendation for the ARD standardization. And the study recommended the following approach. Basically, we introduce the CIOS ARD specification as a base, build on existing OGC and ISO standard, and achieve broad community consensus. The joint ISO and the OGC standard development efforts. And we want to go through a formal standard development process and publish as both ISO and OGC. So the approach for.
So another thing that I wanted to point out is, while ISO is happy to create the standard, OGC is more interested to have a compliance to the standard as well. So how can you check whether some ARD is actually compliant to the standard? So I will just
So to be more different topics, your spatial data is different application domain, require different set of pre-processing that has different quality requirement. So because this kind of diverse requirement, so we cannot use one-size-fits-all approach to define a single ARD standard that is applicable to all the spatial data. So in the
here, I think I'll just say that this project, which has a lot of, so this is how the project is organized, and it's a close collaboration with relevant CIOS committees. Do we agree on everything? No. Do we fight a lot? Yes. Are we making progress? I think so.
So in order to
Okay, I'll just skip this slide and then we'll go here.
So you see, the standard working group was the chart was just in May 2022, and the chart was approved by OGC on May 3rd, 2023 through multiple review and rating and approved by OGC on May 3rd, 2023, and then standard working group held its first in-person meeting to kick off the working group 126 OGC Huntsville, Alabama, in the first week of June 2023.
So these are there, and I should be there too. Ah, there I am. Okay. And this is the project team in ISO, and there as well. Somewhere. Yes. Yeah, there. India PIS.
ISO.
And These are the procedural things. We can go faster.
So,
Lieping is the chair, Patrick Payne is co-chair. We don't
So,
have any nomination from there. Okay. So the standard name is 19176-1. And hopefully, we will have the standard by within 2 years. So we are already in the year 1. So by May, we should have a first draft, April, May. We are expecting, and just being mindful of the time here.
as I,
If I can go, yeah, we will go quickly to the.
so I,
Okay. So this is the timeline, 2025, supposed to be published. We'll see if we are lucky. I think there is one important slide that I want to, this is again the outline.
continue on the outlines, 8, clause 8 is data organization. Basically, define how you organize ARD data in the data structure format. So
Yeah, so
so this
sorry, I should have gone to the previous slide first. So this is what we are doing. We have, and if you see, item number 6 is metadata. Number 7 is data quality. This is what we are doing right now. And the next parts, which is data organization, applied processing, this we haven't yet started. So what we are going to do in a hands-on is the metadata part of it, for which I am, yours truly, is responsible to report back. And this is the top level UML diagram that we have agreed to. Now I'll let Lieping describe it.
one of the important work of ISO 19176 part 1 is to define the general framework in the overall top level UML model for the ARD. And this is very important because this set framework so about each part of ISO 19176 to be plugged in. And in the ISO TC work, we use the object-oriented modeling approach to develop a standard. And the tool uses two models. Standard is UML, so Unicode modeling language. UML is the tool we use to model the standard. And in this case, we define the ARD analysis ready data class is analysis ready data. It's have 4 components. One is just sitting outline. So one first component is metadata, and this will be detailed in the clause 6, as I just goes through the outline. Then we have the data quality. This will be detailed in the clause 7 data quality. And another component is data organization. This is going to be detailed in the clause 8. And the applied processing. This will be detailed in clause 8. And then we also going to have the analysis ready data service, ARD service, that generally is analysis ready data. And then for the first level division, how to, as I said before, because geospatial data is very complex, very diverse. We cannot develop one standard fit all. So we need to divide the standard, divide the data into more homogeneous group, and on that we can develop the ARD specification. So the first level division, after discuss, multiple discussion, now the project agrees that this division. The first, we divide the data, geospatial data, into central product, and also semantic product. The central product basically is the same thing, data, like from data set or from models. And those are central product. And the semantic product is a product that described as geophysics, geographic data. For example, the land use classification data set, the DNA data set, those are semantic products. And another group is modeling product. Basically, the model generated the data set. For example, is a general situation model to predict the future land surface temperature. This is a purely prediction, and those are model generated product. But since those are subclass for analysis ready data, in the future, if user or committee think we need additional group, just do the subclass of the AF analysis ready data about another subgroup. And then we haven't detailed how to divide the semantic product into a more homogeneous subgroup, and also modeling product more homogeneous subgroup. But in the sensor part, we also further divided this into the optical product. This means basically we use the spectral division. So you have optical sensor is basically from the UV to the short wave or the middle wave infrared. Use the optical instrument. Similarly, we have a microwave. So microwave will basically for the radiometric and the sun radar. And we also have a thermal. So this thermal infrared the things in data. And then we also have another group called sound. So this basically for the sonar imagery. So imagery sonar is another group. And then the optical we further divide into the electrical optical and passive optical. So most of the what things in sensor optic is passive optical, but for sensors that generate data is LADA. So this electrical optical LADA. So we will further divide electrical and optical. Passive, and for microwave, we also have this case passive microwave image radiometer and electrical sun in sun. So those these are top level division and the top level numerical model communities of projects agree as I say that the huge part for ARD specification will standardize one small group of product for example ARD problem from sun. So you have a specification, ARD specification, sun ARD specifications that will be part maybe isomorphism 6 4 could be sun ARD selected. But the first sub class or specialized class will inherit all the class heavily defined parent class. So we use the hierarchical development approach so to avoid redundant and repeat definition in the repeat class. So use an object-oriented approach in this.
I will repeat what he says, but I will not claim that this is my idea. So the whole thing is analysis ready data. It will be serviced as an analysis ready data service. Okay. Now, to do that, we have to remember that there are multiple versions. I think he also alluded to the idea that sensors are also active sensors, passive sensors. So you can go into further details as to how you want to subclassify. This is the overall architecture we have agreed to. This is much different from the CEO's understanding of ARD. Why? Because CEO's, I will come to that in my slides, has ARD definitions for different products. So there is CEO's land, ARD land, ARD ocean. So different. Here, what we are saying is we have a generalized view of analysis ready data. It has these components, and it can be either from these 1, 2, 3, 4. And we have particularly said these 4 we will start. If there are more, we will keep adding in this category. So that is where we are, and so there is.
As I said before, one of the purpose was standardization. So what we see in the ISO is that we want to community, broader community to involve this standard development. So in this case, we
so I will just stop the discussion. But yeah, basically the idea that we want have the community involved, and the exercise that we will be doing now for the next 15-20 minutes is basically to understand, take inputs, especially in the metadata. I will stop these slides now and I'll go back to my slides, which is hopefully there. And I'll just very quickly run it through. Very quickly, I'll not. The only thing I want to do from my slides is familiarize with you with the metadata standards of in general, how we classify metadata and use that for the hands-on exercise. So I don't know how many of you know 19115. This is 19115 is a ISO standard for metadata in geospatial. There are 3 parts to it. One, this is the core. Second, which is for extension for imagery and gridded data, and 3 is the XML implementation of the same metadata. So there are lots of terminology we have to remember. There is this metadata elements, there are metadata standards, metadata profiles. So basically what CEOS ends up doing is mixing all these terminology, and that is why it is not a formal standard, because these are well defined. What is a metadata element, what is a standard, and what is a profile. So you can see there are multiple profiles here given, and this is very important. So this is a community profile. Community profile includes minimum mandatory requirements. Okay, they may also not have the comprehensive. So CEOS, if you have, everybody has a chance to see that document. So basically there is mandatory requirement and the minimum requirement, and so community don't need whole of the comprehensive, but whole of the minimum requirement. And what you will see in the CEOS standards, the minimum standards are so low, minimum requirements are so low, it sometimes doesn't even agree to be a requirement. So we are working on that. So ISO 19152 is the most relevant in the context of CEOS ARD. And this is, I don't know if it is visible. I will, next slide. So this is 1915. This is the package, UML package of every metadata, which has different packages inside it. This is the FGDC profile, which includes parts of that, not the comprehensive one, just the parts of it. So it's a community. Now, this is what IMD metadata I said I will come up with. So this is the UML diagram or UML model in ISO for metadata. any metadata. And I think it is a beautiful thing because it allows you to extend. I actually argued that why do we need to do anything else? It's already there, we just need to extend it for ARD. But it doesn't suffice. I will give you some examples why it doesn't suffice and why we need a new metadata for ARD is this metadata has some of the things that we cannot easily ascertain. So, for example, identification of that data itself. It is not easy to ascertain in the context of ARD because it comes from the same. So, there is a MD lineage. Lineage information we will see later on is very information in the context of ARD. So I will skip this one. I thought I would have more time, but I will just skip. This also I will skip because there was something detailed I wanted to show, but okay. The challenge in ARD metadata, as I said, there are multiple definitions of what ARD is. Already you can see some of them here. And the challenge in understanding what is analysis, what is readiness, and what is data. Because when we say analysis, again, DRI, what are we speaking about? Readiness is also, the application readiness for data. There are multiple levels of readiness. So how do you say that is, for what level, what is ready? And what is data? Because it is continuously changing. So for example, the question is if ESA data cubes are analysis ready data or not. That's a standard question that has been come. But beyond ESA, nobody is really using data cubes that much. So should we define the ARD spec for data cube? Again, it also boils down to the volume, velocity, veracity, and variety question related to data. So the ARD, if I have some ARD which is high volume, less velocity, I think I can put in much more metadata. The moment it is high velocity, it becomes a problem. So those things are there. Now let's go to our CIOS ARD spec. So the document that I gave you, and I think even in Lipin's presentation, we discussed that there is a PFF template for self assessment of the metadata for a ARD. Now that template gives how many? Did you see that document? There are two categories. There is a general metadata. There is a pixel level metadata. The general metadata has, I think, around 13, 12 or 13. And pixel level metadata has around 9. Now the question is, do we really need all of that? And I will just, if I can show you, let's see how many of us know this software. Anybody familiar with this software? This is Enterprise Architect, and normally in ISO and most other places, the entire standard, of course, standard is language dependent, but models are language independent. So that is why any standard that we make is to be based on a UML model. So when you saw Liping speak about those packages, it lets you define exactly what do you mean by that package, by the components. So this is the metadata information. This is under 115. These are the things. So what I wanted to do is, given that we have discussed internally in the policy group some of the metadata classes that are relevant to ARD, and we have put some package names. Now that you have seen the CIOS document, I would like you to underline which or give numbers as to which one is the top priority metadata component. You have seen that document. If you want to refer it again, you can. We have that scope for everyone. Yeah, if anybody wants to refer to the document, it's there. Now, all you have to do is very simple. 1, 2, 3, 4, 5, 6. As simple as that. But you can also do more things. Like saying, I don't understand this. Or maybe I understand this, this needs more. So if you see in that document, in the bracket, I have put something like li underscore lineage, md underscore reference system. These are existing metadata classes. Okay, but the problem is some places we have to combine multiple packages to create this. These map these 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 categories, they map to the 13 rough categories that are there in the CIOS spec. So you can number them in terms of what you think is most important, 1, 2, 3, 4, and also another numbering in terms of how confident you are, or maybe not numbering, you can star it. If you are sure that this extent kind of maps very well to the geographic, what is that, coordinates, right? What is the second, the third, no, huh? Reference system. Reference system is there, and then it also extend also. No, not the general. This is general one. It's not. Reference system like this. Yeah, that's very simple. Geographic location is other somewhere. Coordinate reference system. No, no. Two is part of the same. This is generally fine. Bounded box. Sorry. The bounded box. Extend fixed. Right. So, I mean, have a look, see which one you think 1, 2, 3, 4. And if you think one of these is not so important, you can also write like this. Doesn't seem like it is in, because no, that is true. But you know, the challenge is to make sure, because we will be running this with other CIOS participants as well. The challenge is if everybody doesn't have the same perspective of those fields. So that is what we are trying to do in this. So we have roughly, let's say we try to wrap up by 3:50 if we can. So 10 minutes we can do, and you can discuss, we can discuss more details. So extent is like bounding box. Yeah, extent is like, so that is good. If you ask me questions, I can actually show you what it means. I have the diagram up here. I can show you what it means. What are the attributes of extent, for example? So extent and reference system have a mapping. Yeah, there you are. Right? Now, bounding box is a very specialized extent, which is rectangle. Here it is just a polygon.
Right. The bounding box and otherwise
Yes, so bounding box is a generalization of the.
geographic extension is essentially the polygon.
Yes, yes.
Polygon.
Yes, exactly. So, I mean, these are concepts that we have to define as a human diagram as a packages. So we have some packages, we have put those, we have done the map the following as you say. Now the challenge is whether we have done a good job, whether we have done a bad job. If I had a better browser, I would have asked him to do some of the work also. And we are going to run the same program with a lot of other people because we need a lot of the cloud for this.
Because understanding this strategy, one is to see whether the ones without the bracket are to be added in the metadata or like how important they are. And two is to see if they map correctly with the ones in the square bracket.
I have put, I think we have square bracket for each of them. There is something. Okay. The only thing is, which you think is very important. So, like you think extent, if you think all of them are important, don't worry, then that's fine. Then you see how well these have been mapped. Accordingly, you feel that. So, for example, processing chain provenance. If you understand what it is the in the document also you will see how it has been. It is described in the document, and then the document that I have given you, there is a comment from the. So this is peer review also, self-reviewed, and then somebody also tested check. He was really is that correct? So that you should have a look and see will it be captured. So because tomorrow somebody gives a metadata, it needs to be verified. So that is where OGC is interested to make sure somebody writes a spec, it can be verified as well. So that's the question here. We don't want to put anything that cannot be verified. So some of them we have written, I think in the notes, at least one of them I remember it said, it cannot be verified. And given all the data.
You think standard difficult to verify?
Processing chain is most difficult to
Or different way of looking at that.
Yeah, it is most difficult to verify, and then there is something called a citation. So you have to say or auxiliary data you have taken from somewhere else. So how do I know if that data exists still?
So, but here they've written like software version, like what software I would be using, how do you know that? Like if it's a IP of my own, how would you verify whether
Correct.
that version is correct?
Correct or not, and it gives you some code or what. Yeah, I agree. Just put it, and that where does that go in this category? You can only write in this. You can't write over there.
Yeah.
So you have to write it this. I could have made it much more interesting by giving you these things before, but I did not have.
Not required at threshold when fighting targets. What is that?
Yeah, that's not verified at the target level, right? So threshold value, it's not threshold. So they don't have it. So basically, it says that not required. So correction is not required at threshold. It is verified later at the target. So whatever correction has been done, they don't have to have a filter. We can verify whether that correction. That is what there. This is the peer review. This is the comment from the peer. This is a self-assessment. Self-assessment, they have said, okay, this is what the values are. And then peer said, this is not required. So, I think that is correct because you should not be, you don't have to give values for that. Should be, the threshold values should be evident at the target. The target should tell you this is the threshold. You want,
I want to speak.
sit here from it.
I also did computing editor in the art session.
Yes. That part is ISRO is also part of the ARD development of what it is there, but they have no idea what this is. We just take them to this and they say, how do I do? Those ISRO products, for example, this is the CEO's website, I'll show you. They have all other so here are the current specs. All this data is actually taken from here. Okay, what I have given you printout is from here. Now look at the data. Landsat, JAXA, DLR, USGS. Where is ISRO?
That is the first question I had when I went through this site.
They are not even here. ISRO is there. Okay. Finally, there is this. Something is there.
But they've not been like compatible with the standards.
These are futures. No, earlier this was also not there. Now ISRO at least has come up in there. This for
I have one question here. So, instrument would probably be leading to the sensor.
Yes.
Like this. So I'll relate to what we do and I'll ask question in that way in terms of getting our products standardized. So we are not into the business of making satellites or.
right. You are making it to thematic product or whatever sensor data you get,
Yeah.
you would go to the
Yeah.
next step.
So, let's say when we're publishing information, it again depends on the satellite providers, access or wish to grant that information to us or allow us to publish that in the metadata.
So that has to be, that is what the idea is probably.
So in a case where they are allowing us to access the metadata, but they're not allowing us to publish it, where the licensing issue comes in that legality aspect.
Should add it there. So mention
what
that,
happens to
what happens to it.
Yeah.
I agree, just add that information to the comment. Because I agree, it is not always, so unless the sensor, the satellite company tells you the details, how can you put it in the metadata? There's no way.
Look, they would tell it, but you are not allowed to publish it outside because it is their data.
So you give a link to that.
Yeah, like something of that sort.
Yeah.
Then how do you put it in the metadata
As
form?
a reference, I take.
I still add it like.
Is there like citation?
Should we rank it? It's like a rank 1 to 3 work. Can we cluster the rank according to that? Should we like prioritize like 1, 2, 3, 4 in that alignment, or can we cluster the prioritization?
Yeah, cluster. Cluster is also.
I have not clustered it. I've done the difficult job. Because it is kind of, I don't know, like, you do this arena. So
I think we are creating metadata for years now. It's okay. We are all new. It's okay.
but for like,
Yeah.
what I feel as my intuition and everything.
Sure. Please do.
Yeah.
Nobody is telling me for this. You have to write. Oh, sorry. There are three things now. One was the simple task. Which of these you think are given whatever, have you had a chance to see these? Depending on what you have seen in this, which are the things you think are priority packages? Second, I have given some I've done some natural following from existing metadata classes and what yours puts as so what if you think that is right or if you think that is correct. And the third thing that we were discussing was, you know, or you could also rank it or you could cluster it as steps.
An improvement in the version 2.
And basically, you know, if you have any comments regarding these metadata, this is a general metadata, it's not Excel level. One more thing that I would like to see, just finish this, and I'm very interested in that I want to survey. Close that. Yes, sir. We will try to close. Just one interesting thing, once you finish, I want to.
And I also have what is cross-currency.
Okay. So if you have some sensor data, then you have somebody process it to calibrate the data or some error adjustment has been done. So that's one level. Maybe the next. And you have got the ARD at the third. So that is the provenance scale of how it has. If you have any comments also, take your time. It's okay, we will take it. And so now CIOS does something very interesting. There is general level metadata, there is pixel level metadata. Okay, we will appreciate this much more than here. Pixel level metadata is basically things that come to that pixel. So is it mask? Is it cloud cover? Is it those kind of things? If you see the document there also, you will see the fact documents. And by the way, anybody who wants, they are anyways available online, but if you want to just take the document to read later, you are very welcome. I'm not going to carry it. So pixel level metadata is per pixel. Okay. But in the OGC ISO standard working group, we are very clear. We will not call this pixel level metadata. We will call it subset metadata. That means it could be a pixel or a group of pixels. Now we are still discussing whether those group of pixels can have a hole in between. Okay, theoretically, does the bounding box exist and all that we are discussing, but most likely it will be not. It will be just a bunch of pixels, contiguous bunch of pixels, subset. So your criticism or your appreciation for that approach. If you can just, you can say or write or, do you understand what I'm saying? There is metadata, general metadata for the entire ARD. There is pixel level metadata, which is like whether it is a mask cell, whether it is cloud cover, whether there is scattering or something in there. So those pixel level data, we are saying you will not call it pixel level. You will have a generalized class of such. We say it's a subset. So subset could be one or more continuous or contiguous pixels. Right? If you have any points to say, just will be happy. I know there is a criticism also, because how do I differentiate without it? We need an extent, right? It is a similar thing. If I'm going to go sub-pixel, I will need again subset or bunch of pixels. The question will be about the extent of those pixels, right? Whereas if it is one pixel, it is a coordinate in the entire thing. When you are reading it is like exponential. Whereas in bunch, you need extent. So those are criticisms, but please say that, it is complex. It's the computation may be challenging. What if two subsets overlap, partially overlap, all those are challenges, but this is what has been decided that we will take up, because it allows you some other things like edge computing.
One point we need to make there.
Yeah.
I feel that is lacking in the standards. Is the standards for the metadata fusion, because
मैं भूल जाऊंगा, नहीं तो मेरे को लिखना पड़ेगा. I think that is a good point. How to metadata sets? How do I if I'm combining two ARD, how does that automatically or someday it combines? So pixel, the approach of using subset instead of saying pixel. Instead of saying that this is one individual pixel, we are saying it is one or more pixels, contiguous. But I have pointed out to the problem that contiguous is also, we need extent to say what I have pointed out that. So you can have your criticism whether it's a good idea, bad idea, why it is a good idea, why it is a bad idea.
When we have data quality layers.
Right.
Right. So
Data
would that not suffice?
Data quality and metadata. You want to say the
That is the best. We have been data quality layers, right?
Right.
For example, when we have this data.
Right.
We also have this data quality layers. The pixels
Right.
don't have data or pure data quality data.
Right.
They have a certain DM number.
Right.
Right. So when
That is what is now being stored as. So how you store the pixel level metadata, you don't have to store for every one of them. But you can store for the ones where there is a masking. So that is how storing on the metadata is okay. But are you going to do it as a single pixel? Each pixel wise, are you going to have the mask pixel wise, or will you also allow bunch of pixels to be labeled there? Do you understand? Right now, when we say this is a mask, no data, this is a cloud. So we say we tell that pixel wise. Okay? Instead of that, we can do a bunch of pixels.
that is what
The question.
we're trying to
Yes.
cater.
Yes. And in 8 minutes, we have to be out. So, sure.
Okay, so before lunch, if you remember, I was asking a question on as to, like, in Edge, people are already moving towards a completion at raw data, where they're not doing, any radiometric correction or those stuff. If processing chain provenance is added, as per a ARD standard for the metadata, then you would be directly violating, like, if that happens, the product would never
I didn't know. See, if I have the metadata requirement for provenance, I will be able to verify what kind of the processing has been done on this. So the metadata will enforce that whatever data I take for a particular application has done this processing. Now, उसमें अभी ये है कि now we can still tell lies.
No, lies is a separate topic.
Yeah.
But let's say if I'm doing object detection and I'm not working on pre-processing. I'm taking raw images, the model trained it to work on raw images, and I'm giving accurate results.
Right.
But just because of the provenance, like processing chain provenance and that requirement for it to be there in the metadata, it won't be there in my metadata, right? So my product never gets standardized. What
Yes.
happens in, like, that's it's actually.
But then somebody has to take this trade-off between, the ability to produce results quickly compared to doing, all the steps. And that trade-off they have to do. But again, we will not standardize. See, I'm not going to standardize metadata requirement. And you say that metadata you can specify. And then if my application has this metadata requirement, then I have to provide that.
So what I would understand is like this. Because you are a new age provider who is actually taking this clients keep all the process and incoming data to be consumed.
We are not doing that, but that's what I've seen other people do in the conference that I've visited.
No,
Just wanted to know how the standardization work in that case.
the standardization will allow you to, by putting the lineage information, it will allow you to detect such things. Okay, it will not prevent. Still, you can accept such metadata for such level of processing for your. But as long as it is specified, इसमें नहीं हुआ है, you have not done calibration, you have not done this. That mention should be there. Right. Chalo, I think I'll close now with the permission of the volunteers. Thank you.